Another category of indeterminate limits is when we have an indeterminate power. For example, if we try to take the limit of this function, limit as x goes to 0 of x to the x, what we get is a 0 to the power of 0. And of course, that's something that we can't evaluate. So that's an example of an indeterminate limit, infinity to the 0 or 1 to the infinity. Those are three different cases of indeterminate powers. And when you have an indeterminate power, what we need to do is take a logarithm before we're able to take the limit and before we're able to apply L'Hopital's rule. So for example, let's say that this function f of x is x to the x. Well, we know that the logarithm of f of x is x log x. And of course, we can rewrite this as log x over 1 over x. And the advantage of writing it this way is now when we take the limit as x goes to 0 of log f of x, which is the limit as x goes to 0 of log x over 1 over x. Well, now log x goes to infinity, and 1 over x also goes to infinity. So we have a bona fide infinity over infinity limit. So now we're actually able to apply L'Hopital's rule. So we apply L'Hopital's rule, which says that we find the value of the limit by taking the derivative of the numerator and the denominator separately. Derivative of the numerator is 1 over x. Derivative of the denominator is negative 1 over x squared. Doing a little rearranging of the fractions, what we get is the limit as x goes to 0 of just negative x, and of course that's going to be 0. So notice what we have found is the limit as x goes to 0 of the logarithm of f of x. And so that means that if the logarithm goes to 0, f of x must go to e to the 0, which is 1. And so this limit approaches 1. You have to remember, if you take a logarithm, that the limit that you get is a logarithm, and you have to raise e to that power to actually find the limit.